Hello, everyone, and thank you for helping me with the slides. My name is Paulo, and I'm a principal software engineer at Red Hat. I'm here to talk about a topic that I'm interested in, but it's totally unrelated with my company or my work. But let's get started. So I want to talk about how can we fight the climate change with code. So the first question is why. I don't have the answer, but to me, if I was asked why do I want to do this, is because, well, we all see what's happening in the planet. Temperature is rising. The weather is getting all messed up, and I want a better future for my kids and the kids of my kids. So I think that we should take care of the resources we have. So the next question is how. I'm not into politics, that's why I'm in software engineering. I'm more hands-on. So I'm not gonna tell you guys, let's go march and do things. I'm gonna tell how you can do it with code, because that's how I can do things myself. So first thing I want to tell you is, like, when you look at a benchmark, for example, if you look at Tech and Power, and you look at the results, and here I just made a screenshot with where I selected a couple of popular frameworks in Java, because this is mostly a Java conference. You see that there are big differences when you have like a test that does a very common task that we do every day. We make an HTTP request that goes on a database, selects some data, generates some HTML page with a template engine, and outputs the result. And you see here that on the same hardware, and it's like a third-party hardware run by a third-party company, you see that in this, of course, in this case, Vertex Postgres is the first, but it's not the first on benchmark, because I just isolated a couple of results. You see that big difference. Like if you use Vertex, you can do 400,000 requests per second. If you use Micronaut, because it's quite popular right now, you can do 90,000 requests per second. Spring Webflux, 26,000. And if you go on Node.js, you can do 8,000. What I want you guys to grasp from this is, I'm not here to bash frameworks or tell you which one is better. What I'm going to tell you is that probably we can extract some very important information here. The message you should get from this picture is that if you go with a framework that uses a synchronous I/O and is reactive, like the first one, probably you can reduce the size of data center in 5 if you compare it to Micronaut, or 10 if you compare it with Node.js, or even more than 10, because it's just like some big difference. So what I'm going to tell you is that frameworks are not all the same. So how can we do this? First, you need to know your tools. In my normal work, I usually work on a Linux laptop, and the Linux kernel is quite interesting. If you go on your, probably everyone here uses Linux or uses containers which run Linux. So if you go on your file system and you go into a special directory called sys, and on the sys there's like this subdirectory class power capabilities. And this directory is quite interesting because it has information on energy usage of all your hardware. So if you go like look into these files, you can learn a lot about the energy that goes on and out on everything you do on your computer. On top of that, there's like this very cool program, part of the Linux kernel, which is packaged on a separate package, which is called Linux Performance Analysis Tools. And this tool is quite popular if you're doing benchmarks, because it allows you to generate flame graphs, so you see where your application is spending most of the CPU time, but it also can tell you anything about the hardware. So one cool command that I would like you guys to learn is this one. If you run like perf stat, which collects statistics, -a, so from all your CPU cores, -e power energy core, so it will collect statistics on events related to energy on a 1000 millisecond sample interval, and you output it to a file called stat.csv, for example, and you pass a command. It will, the Linux kernel will start collecting all this energy usages of your application into a CSV file, so you can plot nice graphs after. So I just for the experience decide how can you choose a framework on using this kind of information. So as an example, I decided to use Node.js, Spring Boot, Quarkus, Vertex, and I just built a Quarkus native because it's also kind of trendy at the moment. So I wrote an application, and because I'm very lazy, when I write my code, I decide to, okay, I want to make an application that works on all the runtimes, and it's very simple. So it's just a REST API on an endpoint API, so it's everyone outputs the same, has the same output. That creates a secure random byte array of 20 bytes and then encodes it to base 64. So I did it in Node.js, I did it in Vertex, I did it in Quarkus, and I did it in Spring Boot. So as you can see, the code is very basic. So then I run a test, and to make the test fair, I run 30 seconds warm-up phase, and then I run 30 seconds where I get like a concurrency, low concurrency, like 16 requests per second. Then I increase it to 64 requests per second. And finally, I increase it to 256 requests per second per connection. But in order to get things comparable, I need to limit my request rate to be constant. So first I run my test with a very low request rate, so only 2,000 requests per second. So if you look at the results, it's quite interesting. Like, as you saw, like the code is exactly the same, the application does exactly the same, and this shows that if you're using Node.js, which is the yellow line, your CPU is using a bit more than 6 watts. Well, my laptop's using a bit more than 6 watts to handle the 2,000 requests, constant requests per second. If you're using any other JVM-based technology, Spring or Quarkus, you're under the 6 watts. So this already tells you that JVM is more optimized in energy use than Node.js. And then the big difference is that Vertex is using around 4 watts. So you save almost 2 watts per second. So you're saving what, 10, 15 watts, 10, 15% of your energy bill if you just use Vertex, for example. But okay, 2,000 requests per second is nothing. So I run again a new test with 12,350 because I like weird numbers, requests per second. And then you see this, like, okay, it's more or less the same. JVM behaves better than the Node to some case, but then you see that it's not the JVM. It's like Vertex performs always the same way, and this kind of intrigued me. Why is this? And doing a bit more of analysis, it turns out because Vertex API is so small, it doesn't do much. It only does like the I/O and the stuff for you. It's not the code executed on the CPU is way less, therefore it uses less energy, therefore it gets better throughput. So I decided, okay, this, like, my CPU is getting a bit of load, but let's increase this thing. So what if I increase the load? So if I increase the load, the main difference is that only JVM application could handle it. Node.js couldn't keep like a constant request per second. So I increased the load to 42,750 requests per second. And this happened. And I was a bit like, why is this happening? Like, why are now, before Vertex was so cool, now everything is flat the same? And the answer is obvious. Your CPU is maxed out. If the CPU is maxed out, of course, everyone will be using the max energy it can. So if you are using the full capacity of your hardware, it doesn't really matter what kind of framework you use. Then you need to look to the first graph, like what kind of throughput does the framework do? Should I go with a synchronous I/O reactive, or should I just go with annotation-based frameworks? So my conclusion is, like, if you are interested in saving the planet, you should try to learn your Linux command line skills. Use Linux full. All frameworks are not built equally, and well, because I'm a Vertex core developer, of course, use Vertex. And just as a final graph, because I wanted to have a couple of, I wanted to also compare what happens on natives. So as an experiment, I compiled a Quarkus native application and a Vertex application. And I didn't push the CPU to the limit. I kept somewhere in between 28,000, and the result was like similar to the previous result, where everything was aligned. In the beginning, this was a bit strange to understand, but then I realized the thing with native images is that there is no JIT, there is no JVM, everything is native. So it really doesn't matter what kind of framework you're using, because there's no optimizations happening at runtime. So the energy usage will be exactly the same. So a full talk could be made, an article about how to measure things and do more things, but this is just like a very short presentation. Everyone is hungry. Everyone wants to go to lunch. So if you want to connect, just this is my LinkedIn, Twitter, GitHub, and thank you for your time. And if you have any questions, just catch me in the hall. Thank you.